Hello guys, I hope you're doing well, and let's start this conversation, this talk, which is called Groovy DevOps in the Cloud. My name is Andrey Adamovich, and you can see my connection details on Twitter on the screen. So some words about me first of all. Basically, I'm a developer and always try to position myself as a developer. Sometimes I do coaching for my clients, sometimes I'm speaking, like for example now, and also I'm an author of half of the book we are co-author with, which I'm going to talk later a bit. A company called SSIT that I'm working on, we're a small consulting company, so we are basically doing a lot of stuff in Scandinavia and targeting more enterprises. Again, some connection details for me if you want to connect me later. So what this presentation is about. Basically, it is about our take on DevOps and infrastructure provisioning and continuous integration and continuous delivery. So basically it's our path to how we, starting from nothing, starting from our basic experience with Java and Java EE, how we switch to more DevOps-oriented approaches within our projects. So the technologies that we're going to touch in this presentation are pretty much listed on the screen. So this is Groovy, so Groovy programming language. Now, how many of you guys are actually using Groovy in production or in like? Okay, cool. Another tool is Gradle, which is a build tool. I guess you guys all know about it. Jenkins, Puppet, and AWS, specifically the EC2 cloud. So what is DevOps? What is in general? What does it mean? And for most of the people, DevOps is developers plus operations, and essentially it is a set of software delivery practices that you can apply to your organization, inside your organization, to streamline the feedback from production to development and from development to production, from developers to operations, and the other way around. And like many other techniques, like many other principles, like Agile, Lean, and continuous delivery, it's all about minimizing the cycle for the feedback loop between different parts of your delivery process. Where does it come from? Where this word actually appeared, and why it is named like that? Well, basically, in many organizations and in the organization that I was working for, there is definitely a problem of silos, of departments that are focused on a specific part of the software delivery process, and they are trying to only do that, and basically they're building the wall of confusion between each other. So and they're not communicating that much, they're not sharing knowledge that much, and that's why we see a lot of conflicts. A lot of conflicts and wall of confusion, lack of trust, lack of knowledge sharing between the departments, and this can actually become even worse if some of the parts of the software delivery process actually are outsourced to different organizations, and that's kind of a situation we've been in several times when QA was done by a different org, operations were done by a different organization, and this hardens the way you can implement different cultural level changes and the way you can manage the software delivery. And of course, when you have these kind of boundaries and borders, when basically two departments are having some kind of Ministry of Foreign Affairs and they talking to each other through that instead of talking directly, they tend to postpone the deployment. They tend to postpone the integration point. And basically, development is trying to do more changes and trying to see them more often in production, but operations on the other side is trying to minimize the number of changes to keep the production stable. And both goals are valid, but sometimes it tends to go to wrong direction. So the project management is trying to postpone the deployment to kind of minimize the risk, but in fact, they're actually increasing the risk. And obviously, the way you can fight with that, the way you can try to reduce the risk is actually, instead of doing deployment less frequently, you should do them more frequently. This is kind of a way of minimizing the feedback loop. So what is DevOps essentially? And what is it about? It's about more communication, more knowledge sharing between all the parts of the software delivery process, between development, between operations, between QA, between other parties that can be involved in that, and having the common knowledge, common approach, and common team that does that together, not as a separate teams, is the essence of DevOps. And there is another very good definition of DevOps, and this appeared maybe a couple of years ago, which defines DevOps as an acronym of these 4 words: culture, automation, measurement, and sharing. And culture, as you see, is set on the first place. It's the most important part of the process, because without cultural changes on the organizational level, you can't really impose a lot of other things like sharing and measurements and automation. And of course, DevOps and continuous delivery and agile methodologies, they kind of come together more or less, but just DevOps is trying to apply the same principles to operations world and to bring together development and operations. So in that sense, you of course need a lot of different automation procedures, and these automation procedures actually help you to minimize the feedback loop once again. And another important aspect of DevOps is that you have to measure what you're building. So measuring number of users, number of transactions, gathering all the logs, indexing them, trying to search, having the ability to search inside the logs in different servers is quite important, because that's another way of getting feedback during failures, during normal operations, and this is the way to get knowledge. And if you have a common measurement tools, it's actually helping the whole team to understand what's going on in production, what's going on, and how to improve that part in development later on. And these all 3 first points, of course, without sharing them between the teams, inside the whole organization, you can't really do it without sharing that information, sharing the cultural value, sharing the processes, sharing the... when someone hears the word DevOps, usually people think like software development and system operations, but I would say actually it's more like business development and business operations, because business, pretty much a lot of companies are software companies. They're developing software, so developing software is part of the business development. The same goes for the business operations. Maintaining the software for your business is part of business operations, including different other activities. So DevOps is more for the whole business rather than only for software delivery process. That's what can probably be said about that. So, but if you follow different DevOps gurus and the big people in the DevOps community, you will definitely see a lot that they are saying that DevOps is not about tools, and it's totally true. It doesn't matter which kind of tool you use to implement your automation and implement your measurement, but excuse me. But definitely without tools, it's going to be harder. And DevOps is definitely about culture and process, and you will see it a lot. But without tools, it's going to be harder. And in the situations where you are in the position where you can't really influence the culture that much because you're not in the management or you're part of the team that is not influencing that much, then you can actually start with the tools. And DevOps implies a lot of automation. DevOps implies a lot of structure. And without tools, you can't really protect your cultural values. Because if you have a good tooling, that everybody in the team kind of agrees upon, then it's a way to protect your cultural level and to start also changing the organization from top down, also by having the good foundation for that. Another term that often appears in DevOps communities is infrastructure as code, and that's basically something that appeared before DevOps. It's something that appeared before continuous delivery, and there are tools exist that did that quite long ago. The thing is that the deployment process of software, the build, the release cycles, they are pretty much automated. We have tools for that, and most of the developers use them and know them. But not often, well, depending on where you're working with, not everybody tries to automate also the infrastructure provisioning. So creation of server configurations, creation of all the software packages, user permissions, and so on and so forth. But the thing is that it is actually possible, and it is what complements to the whole DevOps initiatives that may exist in your organization. So the idea behind infrastructure as code is that you try to keep everything, including the server configuration, server scripts, and descriptions of what you want to have on the servers inside version control. You try to utilize the tools that maybe you're already using for your development, and at the same time, because it is code, it is something that looks like code, suspiciously like code, you can actually try to ensure that this stuff is actually testable and tested. So the ideal world could be that everything that you do, including software artifacts, including configuration scripts, including test scripts, everything is in the version control. And the way it gets onto your environments is through automation procedures. So basically, for example, if we compare, do you actually do things like that? So uploading class files to remote server and repackaging the jar and then restarting the server. Do you do that? Does anybody do that? No, I guess. Because deployment usually is automatic. And but does any of you or anybody in the teams that you're working in are doing manual server changes? Okay, some. So deployment is automatic, and so should be infrastructure configuration changes. So there's no excuse to not do that automatically as well. There should be no manual changes. So the change in a normal situation, a normal delivery process, the way all the changes are getting onto the environments should be automatic, and that's how you achieve the automation level, and that's how you probably help your DevOps initiatives inside your organization. So at the position where we started, it was like 4 or 5 years ago. We had a project where we had to implement a lot of automation because it just was lack of resources and quite complex infrastructure involving several clusters of WebLogic, and we had to automate that. And the ecosystem included some components that were not really Java related, and we needed to configure the whole stack. Most of the team was composed of Java developers. So we tried to start where we were at that point. Sorry. So our initial tool set included tools like Ant, Gradle, Groovy, a bit of Python, and a bit of shell scripts. Luckily, early enough in the process, we started using Gradle instead of other build tools, and actually we were quite happy after that, because doing something custom and something that is very well integrated with other build tools like Ant or Maven would be a nightmare. With Gradle, it was a bit smoother. So the tooling that we tried, that we kind of needed eventually, and is to also include the infrastructure provisioning into our delivery pipeline, was that we needed infrastructure connectivity. And at that point, luckily, that we had only Linux servers, so we needed SSH connections, and we need to have some integration with libraries for that. After that, we wanted to do some infrastructure provisioning, and after some point, we realized that without proper virtualization, without some virtualization options, we actually can't do infrastructure testing, so that came together with that. So where we started first. So the first blot, we had Ant and we had Gradle, and luckily Gradle has a good integration with Ant, so the whole task library that Ant has can be directly used inside Gradle. So Ant, already for a long time, has two tasks called SCP and SSH exec, and that's basically the way you import them into Gradle through a task dev. So it's nothing complex there. So a simple call to call remote SSH command on remote server was looking like that. Well, nothing fancy. Hostname, username, password command. Very, very simple. But if you guys were on yesterday's talk with Venkat for about Lambda expressions, and when he was comparing imperative style of Java 8 and declarative style of Java 8, then the imperative style has a lot of ceremony. So this code has a lot of ceremony as well. Too much code to do a single thing. Of course, we didn't stop there, because our scripts were going with the time. We were trying to automate more stuff. And because we were using Gradle, and we had all the power of Groovy inside Gradle, we can define methods, we can define new classes, and we can reuse them in the build script. We defined a function which is called SSH, and it basically just did the execution, hiding some of the details of the execution. And this function actually grew to be quite complex because it has to handle some pseudo writes and some special handling of output, and it was quite complex in the end. We also introduced another function for file copying. And inside Gradle, for small tasks, it actually looked quite simple. So this is a task definition of Gradle. Then we had our own configuration management system which were reading property files. So we were executing this command. So it looks kind of simple compared to what you would do in Ant, but still, with the more complex examples, you may get something like that. It's still simple. Still, you have developers can read it, operations people can read it, they kind of understand it, they can write those scripts. But the more complex logic we introduce there, the more complex requirements we had, the worse it got. So the code base, the code base for automation was becoming worse and worse. And another set of drawbacks that we got with that is that on each Ant connection, on each execution of SSH exec, actually Ant makes a new connection, which is not very efficient. And actually with some of the servers, it was a problem with that because they were not really happy about that. Every second we have a new connection, and they were refusing some of that. So sometimes the scripts were failing because of that. And if you look at the way it was done, some of the stuff is just repeated several times. So it's a lot of ceremony, a lot of repetition, which doesn't follow the dry principle. And as I already mentioned, the complex scripts were hard to maintain, and the tasks generally were not idempotent because you had to know the state of the server that you're executing the task against in order to execute the task. And if the state is wrong, basically the task was failing. So what we did, we decided that let's just try a new DSL for that. And we created a library called Sugar. As you may guess, Sugar is a Groovy-based SSH DSL for doing the same stuff we did already with Ant, but it's just more convenient. So as remote command execution, it has file uploading, downloading, and another thing that helps us a lot is that we also implemented tunneling, because sometimes the server is behind firewalls, and you may have 2 or 3 tunnels before you actually go to the actual server. So why did we do the Groovy? Well, first of all, we already used Gradle, so it was a perfect combination because we were already using Gradle for our builds, for our releases. So using Gradle and Groovy together also for our deployments and for our infrastructure provisioning was a natural choice. And Groovy by itself has very mature and concise syntax, and it's extremely easy to produce these cells, similar maybe to Ruby, but just Groovy is actually, because it's supporting 100% of Java syntax and our team was composed mostly of Java developers, learning curve for writing Groovy code is quite small. So of course you have to learn something, but Java developers can almost start using it from day zero. It was a good point for us. And another thing, of course, we actually wrote a book about Groovy. So we have no excuse to not use it, or actually have to use it now for everything. Okay, that's the book, Groovy 2 Cookbook. Anyway, the way you can use Sugar is probably this is just a simple example of how you can use standalone Sugar from a Groovy script. So you need to do a static import, and using the grep dependency management, you can just do it like this. Specify the library, and it will grab all the dependencies, and then you have a set of static methods that you can use to do your connectivity. If you're using Gradle, you can use the Gradle dependency management mechanism to grab the same dependencies and have the functionality. By importing that class, and you get access to default settings. So you can say that you by default connecting with root. You can say that by default you are using the secret key to connect to your servers, and you can set up some login options that you may need. The main entry point for Sugar is the method called remote session, which takes two parameters, and one or two parameters, and in this case it's only using one, which is a closure, which is passed to that, and that's the way that's the way you can call closures in Groovy, just passing the parameters like that, and you can set the URL where you're connecting to, and after that you're just executing the commands, like in a similar way, just maybe with much less ceremony than was in the first examples. We also introduced a couple of abstractions to help to work with remote objects, and one of them is remote file, and you can, by referencing the remote file, you get an object which has some methods, and one of them is set text and get text, so you can set the property of the content of the files in a similar way you would do it in a normal file in Groovy, just with a single command. So in this example, it just copies, sets the content of the file to enable equals true by this single command, but underneath actually does ACP calling. And since Groovy supports multi-lines, you can actually set the whole content like that. So, and I hope it looks like it's readable and you can understand what's going on with quite easily with Ant, and it maybe was a bit more verbose. Also, there is a way to copy files, and it is kind of similar to the way Gradle implements copying files, but local file copying. So you can specify that you're doing SCP, then you do from and into, and then you can specify whether you do it from local directory into remote directory, or you can switch the order, so it's either uploading or downloading depending on the order. And you can have a list of files, a list of dirs, and in this way you can very easily copy the files. Another goodie that Sugar introduced is that you can actually, the exec method returns a command, returns an object that has data about what the command actually executed, what was the result of the execution. And as you can see, you can check the status, the exit status, and you can also get the output and then iterate through lines and probably do some logic around parsing the output of the command. But as you can see, this code again, it maybe has too much ceremony because you have to check the exit code, you have to know the exit code. So we also added some shortcuts to make the code look very simple. So you can just do if OK this command. So we'll just silently execute the command without showing the output and check if the exit code is 0. And the same for other one. So in this way, we could write very concise Groovy scripts and Gradle tasks to do remote server controlling, provisioning, and orchestration. And at the same time, we could reuse some of the features of Gradle dependency management and integrated with other infrastructure that we had for building and releasing and testing. So within the same build script, within the same structure, we had everything at this point. And there's another example of tunneling. So there's a tunnel method, which basically you can start a tunnel on IP address and port, and then it starts a new server, socket server on a random port, and you get it inside your closure. So you can use the local port variable to actually do something on the server. And this particular case is a task for flushing the cache of the remote web server. So it's getting the URL and executing the text and comparing the result. Another couple examples is that you can also use, you can set up prefixes for the commands. For example, if you would like to execute the sudo for all your commands, you can just specify prefix and sudo, and then inside the closure you can pass. You can just use the normal methods that you use in other contexts, and the same for suffix. You can also output, for example, everything to a single log. Sugar was a nice addition, and but still complex scripts were not that easy to maintain yet. And again, to create something that is idempotent, so tasks and scripts that can be executed as many times as you need, and they would just verify the state. It was not the case. It was very hard to write anyway, and you had contain some logic that you need to implement. So, and we eventually realized that people already thought about the problem, and there should be some tools that do something like that, and so we stopped on Puppet. Puppet is just one of the tools. I mean, it doesn't mean that you need to use Puppet. There are tools like Chef and Ansible and Salt. So, but we chose Puppet for several reasons. One reason is that probably it seemed to us that it was more mature than competition. It had large community, probably larger than the others. But the most important part of choosing Puppet was that it has quite readable DSL. And if you remember the talk from Dan North on Keynote, he said, let's ask Phil. So we didn't really ask operations about it, but we showed them the examples. But as soon as they see the examples, they can actually be on the same page. They see the DSL that they can understand. Developers see the DSL that we can understand. So, and this was the main point for going forward with that, because the DSL is actually readable. And we actually had problems after that with that, but the first attempts was quite a good point to go there. And we had good acceptance rate from developers and operations to actually use Puppet as a tool. And another thing that Puppet and apparently many other operations tools, they actually are written in Ruby, not in Java. So, and Puppet DSL, it's not Ruby, it's a separate language, even though Puppet itself is written in Ruby. But because Puppet DSL Puppet has this abstraction layer in front of DSL, we don't need to learn Ruby in order to use Puppet. This is not true about, for example, Chef, where you have to learn Ruby. So we have this abstraction layer between operations and development. So we don't need to go learn a new language. Well, no, certainly not, at least not in a new programming language. So the way Puppet DSL looks like is, I hope it's extremely simple. This is the way you define resources in Puppet. So here you have a definition of the package that you want to be installed on the system. And then, actually, by the way, this is a good way to fight the heartbleed problem, because if you update your SSH package, it will be no bugs in that, hopefully. Because what you do, you ensure that the version of the package is latest. So, and the good thing about this definition is that actually it is idempotent. So you can run it as many times as you want, and Puppet will just verify that if the package is installed, it will do nothing. If the package is not installed, it will install it. If the package is not the latest version, it will try to update it to the latest version using the package manager of the underlying operating system. So it could be Red Hat and Yum. It could be Ubuntu and Debian packages and apt. So it has that abstractions, and it allows you to make a declarative definition of what you would like to achieve and have abstractions over the operating system primitives. The next resource type is defining a specific configuration file that you want to place on the system, and you put it on this location, and you give it this user and group. And you also, another thing that you can do in Puppet, you can actually set dependencies between resources. So in here, we say that we require package SSH, and that means that this file will be placed on the system only when this package is already installed. So Puppet will check that. Another thing that is that if this file is changed, if we change the configuration, then Puppet will actually notify another resource type, which is service, and which is defined later on here. So what we define here is a dependency graph between your resources, and Puppet takes care of that. Compared to if you need to write something similar in a scripting language like Bash or Sugar, taking all the things that Puppet actually does behind the scenes and implementing that with the scripting will take much more code lines than this. So this was a good trade-off for us, even though Puppet is not really Java related, it's written in Ruby, but still it was a good trade-off for us and helped us to isolate certain things and to finally have idempotent tasks that in a declarative way define what we need on our infrastructure. So just a brief introduction how Puppet works. So if we have a new server, first thing what we do, we install JOS. And JOS is not a new operating system. It's an acronym for Just Enough Operating System. So something that you install initially on your machines and something that probably already has Puppet inside that. Then you set up networking, so you have connectivity, and then you define manifests inside your version control, and Puppet can take them and apply them to the server to make the state of the server to be as you want it to be. And as I already mentioned, Puppet is idempotent, so if the server is in the state which we don't want it to be, it will actually make it that. And if Puppet is running periodically with the cron job or through the Puppet master, then if someone has actually changed the configuration, then Puppet will restore it. So in that sense, Puppet is not only installation tool, it's not only provisioning tool, it's also kind of an audit tool. So you can actually check what's going on and fix it. And that's definitely a huge step forward comparing to just Sugar and Bash scripts. Another good thing about Puppet is that you can actually create configuration modules. So you can package your application configuration, you can package your software packages configuration like caching or monitoring or something like that into a module, and you can deliver it as a package. So configuration is finally packageable and deliverable. And the way you apply modules to the environments, to the servers, is basically the same as you would do with the resource types. You just reference, I want this module on my server, and this is probably one line, so I want Apache to be running on this machine. I will just include Apache, and Puppet will just install it based on the module setup. And Puppet has a lot of different modules. And a lot of them, there's a special site called Puppet Forge, where you can find modules supported by Puppet Labs, which is the company supporting Puppet now, and also a lot of open source modules. And also GitHub contains crazy load of those for different things, for databases, for security, for messaging, for monitoring, for whatever you want. And of course, you can write your own. You can write your own, and you can publish them. You can use them within your organization, and that's a step forward for the DevOps initiatives. So by using Puppet, by introducing Puppet in the organization, we made a quick proof of concept of just Sugar plus Glider plus Puppet. We minimized some of our tasks to just doing uploading of Puppet manifests and running them. So a lot of our infrastructure management code minimized to just these two tasks. So upload modules, we zip them, we push them through the server, we unzip them on the local machine, or on the remote machine, sorry. And then we have another task called Puppet apply, which is calling Puppet apply command to apply the manifests or the modules that we want to be on the machine. So a lot of installation tasks, a lot of provisioning tasks were minimized to only these two, because now we can define everything in the manifest in a declarative way. So this definitely helped us to separate infrastructure state description and infrastructure provisioning from operations and orchestration tasks like, I don't know, cache flushing or server restarting and stuff like that. And scripts definitely became more maintainable and more idempotent. In the meanwhile, we actually started developing complex and more generic Puppet modules for the same project and for our other clients. And because module is nothing more like a package, and it's quite similar to a jar, actually, modules needed some testing, some proper testing, and sometimes on different platforms. So how do we actually test it? So it looks like code. So in Java world, we usually use JUnit to test our code. So why not to use that as well? So what we did, we introduced another small library just to wrap around JUnit we called it initially Puppet Unit, but now we're probably just going to rename it to Provisioning Unit because it can be applied to other tools like Puppet to actually test the result of the provisioning. So it's a simple tool that just checks the remote state of the server. And it's just an integration between Sugar and JUnit. And because we're using JUnit, we can also reuse the reporting features of JUnit. So a simple example of a test for Derby module. We created a Puppet module for Derby installation. And a simple test, before the test, we apply the configuration using the special command called apply Puppet configuration to the environment. And then we can write some tests like executing the commands and checking that remote file content is containing something, or and we can just write asserts about it. Yeah, just another type, another set of asserts. We can check that we can check remote commands that are executing, and we can check again the file text contains some errors, that scripts that we uploaded and we run remotely return the results that we expected, and just again checking different types of stuff like ports opening, file text containing something, and so on and so forth. And the thing is that because we're using JUnit, we are in Java world and Groovy world, where we can take the whole power of all the Java libraries and make them and use them to test the environment state. For example, we also wrote Puppet Jenkins module, so a module that installs Puppet on the machine. And because it was running behind the firewall, the test that tests its state is actually starting a tunnel. And then what we just use HTML unit to actually test that we do a login, and we send username, password, we do a submit, and then we test that actually the user that was created by the module is actually there, and it's actually the UI is started and working. So this is an integration test for the result of the Puppet Jenkins module. The same we did with, for example, Subversion Puppet module, which we also implemented. And again, we just reused the library that's already there for testing SVN functionality. So we do the SVN login, we do different preparation phases, and then we just check that after the module installation, the repository that we created and we're connecting to is actually empty, and we're trying to commit something to that to see that actually it's working. So we're testing the result of provisioning using the Java libraries and then JUnit and Puppet unit. And yeah, several asserts in the end. So it's pretty much like normal JUnit test. So, and of course, because we already had using Gradle, using Puppet, using Sugar, we had to run all this in a continuous integration server, and we use Jenkins. I guess there's no reason to explain why we use it, because it's just so popular and so easy to use, so there's no excuse to not to use it. And for example, here you can see screenshot from Jenkins that actually shows the result of the test of the provisioning result of the Puppet module applied to the machine. So it is pretty much like, looks like software development. It looks like we tested something that is just code, and it is just code. We're testing the result of the code. It's an integration test for the module, and we see the same things as we would see with the normal packages, normal Java code. So the next problem that we tried to address is that we needed to test some of the modules on different operating systems, and we needed to test them on multiple different architectures, and we didn't want to do it on real servers, so we went to Amazon Web Services, and specifically to Elastic Compute Cloud, which is quite probably the most mature cloud on the planet at the moment, and has great API, and it provides a lot of different hardware variety, meaning that we can actually launch quite powerful instances. And for some of the modules, for example, for the logic modules that we created, we had to actually launch M3 large to make a test happen, because otherwise it was failing out of memory. And also it provided us the operating system variety, so we can run Red Hat, we can run Oracle Linux, we can run Ubuntu, and because those were the systems that our clients were using. So we can provide a Puppet module to them, which was tested beforehand, and they can just use it to apply to their environment later on. So to address that, we created another small library called Gramazon. It's a very small one, and it's just has a few tasks at the moment. But we just wanted to integrate it to the whole into Gradle and into the whole of stack to make it to make happen in the same tool. So it's just another Groovy-based API for interacting with EC2, and it has integration with Gradle. So the basic stuff it has is just you can start an instance, and you can specify the different security parameters. You can specify the instance name where you want to start, and you can also specify the state of the file where you save the state of the configuration parameters of that instance. And the most essential, the most important part here is this AMI ID, which is an image of operating system image which you're going to use to test. It could be, in this case, I think it's Ubuntu, but it could be anything, and this AMI ID depends on the region that you're using. And then another important part is the instance type. So for some of the tests, we needed to actually, for many of the tests was enough with 10.1 micro, which is the cheapest and the simplest instance type. But for some of them, we needed to adjust that to be bigger. And another task is terminate instance, where we just specify the same file that we used to start the instance, so it knows the instance ID and other parameters, and it can terminate that. So the flow of the testing of the configuration, of the Puppet module configuration, was that we're starting the instance, or instances depending on what we're testing, we're uploading the manifests there, we run the JUnit tests, we generate the report, and then we terminate the instances. In case the tests were failing, we are not terminating the instances, so that people can actually check why it failed and check the state of the service, so they can see what's going wrong. And because some of those instances were actually running for a long time, there was also a special script to actually kill the long runnings, so we don't have some garbage running for a long time. Another issue that we also eventually faced is that we actually needed to support customized operating system images. Initially, we only used the default ones that are available on AWS Marketplace, but because some of the tasks actually run for a long time and the longest part was like some long provisioning scripts, we needed a way to create images with some pre-configured software, like Puppet and latest packages and stuff like that. So we created another simple tool that was a wrapper around some other AWS APIs, which was actually inspired by Packer, which is a similar tool, which I think is now much more advanced than what we did in Imager. But still, we kind of integrated Imager with the same stack that we had. And the simple example for Imager is looking like that. So again, you specify some parameters for AWS connectivity, and you can provision your newly started instance, and then Imager will just create, after everything is run, it will run it will package the operating system image and save it to the repository, and you can use. It will generate a new AMI ID, and you can use that AMI ID later on in your tests. So to summarize all the things that we touched in this presentation, is that what we found is how the work of provisioning infrastructure actually is split, and how different stages that you have to follow is divided in these 3 areas. So you have to support images of testing environments, for your production environments maybe, and you have to have tools to be able to create images and recreate the images. So it's not a manual process, but an actual automatic process. Also, by separating the way you define the state of your servers in a form of declarative manifest, where we used Puppet a lot, is as the middle level, and the last level is the orchestration and the operational tasks that are not otherwise done by the provisioning scripts. And just to summarize, the big picture is that we used the base tools like Gradle, Jenkins, and Puppet with some syntax sugarcode on top of that, with the libraries that we wrote, to actually implement connectivity, testability, and modularity of server configuration. And that works for us, and works perfectly for us still. We kind of called all that iAutomation because it's the name of our company is iAstus, so we thought it's a fun name to name it off. So to conclude, what we achieved during the last few years is that we're trying to reuse the existing Java knowledge that we had and that our team had. We're trying to build a bridge between devs and ops, and to make some trade-offs, like some using Puppet instead of trying to write something new. And we try to reuse the same practices we use in software development. Also, we try to apply them to operations, and we're not afraid to try new technologies, and we try to automate as much as we can. So next steps for the toolset that we created is probably create more documentation and examples for that, add more DSL methods so it's more convenient to use and has less ceremony to use, extend, have more integration with Gradle on that. Also another thing that we probably would like to have is have more Windows connectivity, because it's a huge market share that is not that well covered yet. And we would like actually to go in that direction as well. We would like to define a richer model for EC2 connectivity, and we probably would like to extend to also not only to Puppet, but also to other provisioning tools. So just to mention some reading material, there is a book called The Phoenix Project. Probably you guys heard of that, but it's not a technical book, it's more like a fictional book, but it's really interesting read about different DevOps culture points of view, and it's quite interesting. Continuous delivery, of course, you have to read it. Another book that is similar to continuous delivery is called Release It, which is also quite interesting for many reasons. To play more with the EC2, you can probably look into Amazon EC2 programming book. Definitely for getting better, more understanding about how Gradle works and how you can use it in your environments. You can also read this book, Gradle in Action, obviously. So a set of technologies that you may want to follow in the terms of automation and DevOps in general are Vagrant. Vagrant is like a local virtualization tool that you can use for starting your local machines, local virtual machines to test stuff. So you can, on your local laptop, you can actually start environment that is very close to production and provision it with the same scripts you would use, that we use to provision production. Also, Docker is another way of virtualizing. Packer, as I mentioned. Camo is another virtualization tool. Also, there is a good library in Java world called JClouds, which integrates with many different cloud option providers. And if you are into Jenkins, then probably you have to follow Cloudbees, which are the ones supporting that now. And one more thing, all the libraries that were mentioned, it's all open source, and you can find the source code on GitHub. And we are definitely seeking contributors. So if you would like to test it or to submit your pull request, we'll be more than happy to hear anything from you. Okay, I think I'm done with the content. Questions? No time? Okay, so I guess the question, you can ask questions after this session. Thank you.